Hey guys, this is Miss Bendon. Welcome to day 2, or at least video 2 of online learning. Maybe some of you guys are just knocking these all out Monday, I don't know. So we're going to review the geometric series formula today for my Miss Mansour's class. This is still review for Miss Kaufman's class. I think this might be new. And to start out, I'm asking you, what's the difference between these two questions? The first one is, given the sequence 2, 3, 4.5, 6.75, find the eighth term. And the second one is, given the sequence 2, 3, 4.5, 6.75, find the sum of the first eight terms. So of course the big important difference between these two questions is the word sum. For that first question, we're just finding the eighth term of what is a geometric sequence, so we can plug right into that geometric sequence formula. A sub n equals a sub 1 times r to the n minus 1 power. So we can just start to pull that out. A sub 1 is going to be the first term. So a1 in this case equals 2. And then spotting that r, that common ratio, might be kind of tricky for this one. It's not super easy off the top of your head to go 2 times what equals 3. So what we can do is work backwards and do 3 divided by 2 in our calculator. Gives us 1.5, and that means that 2 times 1.5 is 3. And we could test that. Pop into your calculator 3 times 1.5 and see that you get 4.5 out, and so on. So r is 1.5, and then if we're finding the eighth term, the term position is n, so n is going to be 8, and we've got a sub 8 equals 2 times 1.5 to the 8 minus 1. So 2 times 1.5 to the 7th, which is 34.17. They didn't give you any specific rounding instructions, so I'm going to round to the nearest hundredth there. And of course, if we're asked to find the sum of the first 8 terms, that means that for the first 8 terms, we're not just finding the eighth, we're finding 2 plus 3 plus 4.5 plus 6.75 all the way up to 34.17. So yesterday, or in the previous video, you learned one method for doing this, which was sigma. And with sigma, we could plug in to that sigma notation in our calculator. And if we're finding the first 8 terms, we're going to go from term 1 to term 8, and then put in that rule that we just came up with, that 2 times 1.5 to the n minus 1, except it's not n because I just called it x underneath the sigma, so it's got to be x a second time, to the x minus 1. And that's one way to do it. But what we're also going to learn is the geometric series formula, which is up here at the top of this slide. That's the geometric series formula. And the variables in that formula are really going to mean the same thing that they mean in our sequence formula. So we've still got that a sub 1 equals 2, and we've still got that r that's equal to 1.5, and we've still got that n that's equal to 8. And so if we plug this in, now instead of a sub n, we've got s sub n. So s sub 8 means the sum of the first 8 terms is going to equal 2 minus 2 times 1.5 to the 8th. I'm just replacing all these variables over 1 minus r is 1.5. And so then we're putting this into our calculator to get out an answer. And easiest way to put something like this into your calculator is going to be to hit that alpha button, y equals, and then enter. And that's going to get you a fraction on your calculator so that you don't really have to worry as much about order of operations. And you can just put the top of this into the top of that fraction and the bottom of this into the bottom of that fraction. If you're just using division, instead of putting it into that fraction form, make sure that you have parentheses around your entire numerator and your entire denominator. And when we put that in, we get out 98 point, I'm going to round to the nearest hundredth again, so that'll be 98.52. So that's how we use the series formula. And this series formula works specifically for geometric sequences when we're adding them up. You don't have to know this proof, but I'm going to put it up in the background while I talk for a minute because it's something interesting to look at, but it will result in that series formula, which is given to you on the Regent. You can always use sigma to find the sum of a set of terms. So in theory, you could always use sigma instead of this series formula. The advantage of the series formula is that in order to use sigma, you have to be able to figure out the actual rule, which can sometimes be complicated, right? But to plug into the series formula, all you really have to be able to find is that a sub 1, that r, and your n. So if you can find those three variables, you can use them without really having to fully create the equation. Sorry, I'm losing my train of thought a little bit. All right. So what we've got here is a Regent question that we could solve with series. And this is an example of what I mean when I say the sigma would be a little bit trickier because we'd have to put together the whole rule. But for this one, we can just plug in. So a 7-year lease for office space states the annual rent is $85,000 for the first year and will increase by 6% each additional year of the lease. What will the total rent expense be for the entire 7-year lease? So my first question to you is, what tells you that this is a sigma or series problem? What tells you that you're adding things up here? And of course, the big word that jumps out is the total rent expense, not the rent expense for year 7, but for the entire 7-year lease, meaning we're adding up the first year plus the second year, plus the third year, plus the fourth year, all the way up to the 7th year. So we're going to plug into this series formula, which means that we need to find our a sub 1, which is going to be that for initial value or that, first year. So we've got that right here. The first year is $85,000. What is it doing? I just want to highlight. Okay. $85,000. And then we need to find that R. And we can see immediately that we have that increase by 6%. So we've got a rate of growth of 6%. But if we just plug in 6% or 0.06 as a decimal, that's not quite going to work. Because that's not really my common ratio, because if I take 85,000 and I multiply it by 0.06, I get 86,000 times 0.06 is 5,160. Your rent for year 2 is not going to be 5,160. It's going to go up by 5,160. So what we're actually multiplying by is not just the 6%. We're multiplying by 1.06 because we're keeping that entire 85,000 and then going 6% further. And that's why when you plug into the exponential growth formula, it's sort of built in there for you as that 1 plus r. The common ratio is that whole 1 plus the percent. So it's going to be 1.06. And then what's our n? N is just going to be the number of terms we're adding up here, which in this case is 7. So we can plug into that formula. S sub 7 equals 85,000 minus 85. I'm going to run out of space. Let me move these over. 85,000 minus 85,000 times 1.06. I still ran out of space. To the 7th over 1 minus 1.06. Remember, your calculator trick is you plug that in, you're either putting parentheses around the numerator and denominator, or you're using that alpha y equals enter. So give that a try, plug that into your calculator, and let's see what we get. I got $713,000, 476 and 20 cents, because remember, we're always rounding money to the nearest cent. Can you see that decimal there? Bad handwriting. All right, here's another Regent question. This one's got another trick to it too. The first term of a geometric sequence is 8, and the fourth term is 216. What is the sum of the first 12 terms of the corresponding series? I'm going to help you figure out R, and then you have to try and plug it into the series formula on your own. So the trick to this one is that we know the first term is 8, and we know that the fourth term is 216, but we don't know what the terms in the middle are. Here's what we do know, though, is that we're starting at 8, and we're multiplying by the common ratio to get to the second term. And then we're multiplying by the common ratio to get to the third term. And then we're multiplying by the common ratio again to get to 216. So 8 times R times R times R equals 216. And how could we rewrite R times R times R? R times R times R is really just R cubed. So 8 times R cubed is equal to, is equal to 216. And then we can just solve for R. So I'm going to start by dividing both sides by 8. 216 divided by 8 is, what did I do? 216 divided by 8 is 27. So R cubed equals 27. And then we're going to take the cube root of both sides, which you can plug into your calculator. I think you have to go into the math menu, and it's the fourth option. But I do know off the top of my head that the cube root of R of 27 is 3, so R is going to equal 3. So that's our R value. Go ahead and plug in to that series formula to find the sum of the first 12 terms of this series. All right, so I plugged that in. S, whoops, why is that not writing? S, there we go. Sub 12 equals 8, because my first term is 8, minus 8 times 3 to the 12th over 1 minus 3, and I got 2,125,760, which is multiple choice option 3. We never mentioned this one was multiple choice option 4. We never actually filled it in. I just realized that. All right, guys. So we've gone over the series formula. We've aced 2 Regent questions on it. Go ahead and go do that O2 series delta math. Give it a try and get in touch if you need a hand or if you just want to say hello. We miss you. Haven't heard any funny jokes from teenagers in like over a week now. So definitely email me and say hello. Bye. Bye.